Firstly, thank you for attending my presentation. Today's topic is C4 model with observability. Uh, for those who don't know what C4 model is, I would be covering that in short. But the focus of today's topic is C4 model with and aspects to observability. Typically, what we've seen in the past 3 decades, the software architectures evolved from monolithic to more modern architectures such as microservices, front-end based, component-based architecture, Flux, Redux, MVVM, microfit, and data architectures. Now, representing these architecture in the form of diagrams for different target audiences like business, software, architects, developers, testers, and infrastructures. Now, this ideally means that you're going to have different visual representation for each one of them because a security engineer or security team would be more interested in the security aspects of the architecture rather than look at the business side of it. And likewise, the infrastructure and the deployment again have a very different viewpoint on the architecture. So some of the architecture views that we have seen typically are information business architecture, software architecture, conceptual, logical, physical, which kind of comes with the breadmeer, you know, uh, scheme of things. Data architecture, component architecture, deployment architecture, infrastructure, and security architecture. Now, while we've kind of talked uh, so much, I would like to take a minute and talk about the software development methodology and why software development methodologies. Now, with the methodologies, obviously there is architecture, as one of the phases of the software. And when we represent architecture, we obviously have certain architecture views. We've seen from waterfall to agile, everything between the 60s to 2012, and obviously this is not kind of covering the new ones, which is something which I would do that in my next presentation. Now, the most famous one, typically what we've seen is, something which came out from IBM in 1996, 1996-98 timeframe called the Rational Unified Process. The Rational Unified Process had one such way of representing architectures. They called it the 4 plus 1 view. And they basically would typically talk in terms of the logical view, the process view, the physical view, and the development view. So they had some semblance in terms of connecting the various architecture views and kind of basically take it down to the developer side of it. But they really couldn't do a very comprehensive job. So when you actually start, when you are architecting software, you typically will start off with the information, the business architecture, and kind of work your way down to infrastructure and security and deployment. But the point is traceability across architecture all the way down to the code is something which is the need of the hour. And that's exactly what C4 is trying to solve. C4 is not a new methodology or nothing of that sort. It's just another way of representing um, architecture views. A little bit slightly more logical in the sense, trying to take it all the way from business down to the code. And plus, it kind of enforces some level of traceability and making communication across the various views to different target audience a lot more easier. Now, with the fast changing business needs, technology architectures, have kept up with time, such as Microsoft architecture and modern. Although the architectures views are focused on communicating with architectures of software system with clarity. So, as I kind of mentioned, what is really required is connected views, drill down capabilities. For example, if you're building a software, let's say accounting software, for example. So at the very high level, accounting software would be interacting with a lot of third-party systems. And so from a business standpoint of view, they would be more interested in knowing the accounting software as a black box and how it kind of interacts with the outside world. And as we kind of go down, the technical folks will be more interested in knowing what's happening inside of the accounting software. And then eventually, when you kind of the design side of it, you want to know what components are really trying to come around to deliver the functionality of the web front end for the accounting software. And similarly, that kind of ties into the code. Now, this as I kind of mentioned, had some semblance. There was some I would say some progress had actually been made from the rational unified point of view, but they really didn't do a good job in terms of connecting it down and even articulating in terms of how to enforce traceability in architecture all the way down to the code. So C4 ideally basically helps you, take everything from the business down to the code, introduce traceability, and thus it helps a lot from change management standpoint to be a lot more easier. So at a very basic level, C4 involves four different views. The context, basically, which talks about the business, the containers, which talks about the technical components which are involved, technical elements which are involved, which kind of bring everything together. The component is essentially your component diagram, and the code is a class. A C4 model is a visual representation of the framework used to describe and communicate the software system. It provides a set of hierarchical diagrams that progressively zoom from a very high level overview to a granular details, of the system, which we are talking from an architecture code standpoint of view. So I'd like to take a minute and kind of take the same loan processing example from a C4 standpoint of view. And now this is where I'm going to start talking a little about observability and how where it starts can. So monitoring and alerts typically is a third party or is a system which it's a third party system, or it could be already kind of be put in as a part of the code. But I'm going to get back to it later. So context out here is basically, it's kind of showing loan processing as a single package that in turn talks to other systems in terms of credit scoring systems. And as you kind of move into the container, you can actually see that the loan processing is actually blown up to kind of give all the specific technical elements which kind of bring together to get the functionality of loan processing. In this case is that you can see the container which actually has a web application, mobile application APIs, and the database. Now, furthermore, as you kind of go down the component level, you probably want to understand what's the web application really kind of made of. So it's kind of like you drill down on the application and you're going to say, oh, it's got a loan processing service, and in turn it calls a credit card check service, and eventually that calls a risk assessment service, and that's how it kind of shows in terms of how all of it kind of comes together, and that in turn is tied down to classes, which is the actual code implementation point of view. So you can see how nicely we've taken the loan processing, loaded down all the way down to the code at a class level. So context, container, component, class, or code. That's exactly what's kind of done. So need of having visual representation framework, more focus of describing communication, the various aspects of architectures clearly has been a gap. And C4 model is a visual representation framework used to describe and communicate the software system. Now, it provides a set of hierarchical diagrams that progressively zoom in from a very high level view overview to granular details. And essentially, we are talking about architecture to code. So that's exactly what we are doing. C4 really kind of brings architecture to code down traceability. And that's why it is so beautiful. And that's the reason a lot of the companies have begun to start using C4 model, because it really, really pushes the bar from a traceability standpoint of view. So I'll take a minute and then I kind of go deeper into each of the layers. So let me kind of talk about the context. So the context is basically the highest level of how the system under consideration with external dependency. Now, this helps the non-technical stakeholders understand the system's overall purpose. The first C, as we call it, the context, which is the highest level abstraction that provides a big picture and shows how the system fits in the overall world and interacts with the other systems. The purpose of the system context diagram is to provide an overview of the system boundaries and its connection to the outside world. It helps the stakeholder understand the system's points, interaction points, dependencies, interfaces with the external entities, and facilitating the discussion about integration, data exchange, and systems boundaries. So you really look at the context in terms of loan processing. You have loan processing, and which is a single box, and that interacts with a lot of other systems. In this case, it's going to retrieve the credit score from the credit scoring system. It's going to interface with the core banking system for a lot of the the other needs, and eventually it's also going to report out to the regulatory reporting service in terms of the from a reports which need to be sent from a regulatory standpoint. At the same time, we've also kind of given who are the actors who are going to be using. So in this case, borrowers, loan officers, risk analysts, and administrators. So it kind of gives a very holistic view of the system to the business in terms of what the boundaries of the systems are, what does it really interact with. At the same time, not getting too much into the details of what loan processing is all about. We don't want to talk about that. So we just want to leave it at a point where it's extremely high level because the target audience for something of this nature is are non-technical and they don't really want to kind of get into specifics in terms of what loan processing is all about internally. But as we kind of move ahead, we like to basically kind of look at, the technical side of the context diagram or the content. The context diagram was heavily focused on the system interaction at a high level and makes sense to the non-technical folks. Now, as we move deeper into the architecture, the next stage, which comes post the context diagram, is the technical architecture. The container. So just to kind of be, on the same page, we're really not talking Kubernetes or Dockers. This container came much before Kubernetes, but for some reason Dockers became more famous. So that's why. But the container out here is a drill down of each system component, but a more detailed view. For example, the loan processing application will be comprising of the web application, web and mobile, API facade, and database. Now, a context diagram in the C4 model includes several elements that help illustrates a high-level technical architecture and the interaction of a software system. Now, these include the system. This represents the system. It's usually a large box enclosed, with all the other elements. The containers, they're high-level technology facing. Container represents the application or data store. Example: a web server, database, mobile app, standalone application, file system. Each of this got to be labeled with the name of technology, if appropriate from an interaction standpoint. So basically, we also start talking about interactions in terms of the arrows, in terms of which, contain, which part of the containers are actually talking to what in the entire thing. So there are communication part between the containers, and they show the lines that which are annotated and a brief description, for the interaction of the protocol used in terms of communication or REST or SOAP or AMQ. So messaging piece also kind of comes in. And at the same time, you have the users as well. These are the actors who are going to interact with the system, represented on how the system context diagram. They could end up users, administrators, and other types who interact with the other system. The external systems, basically, these are the other systems, which your systems interact with, like users. They are represented similarly, and how they are, how they are in the system context. An important note that aim of the container diagram is to show the high-level shapes of the technology choices of your software systems and how responsibility are distributed across. It doesn't delve into the details of the software architecture within each containers, and that's the reason because and that's a part we have the component of it. I'll take a minute and also talk a little bit on the previous diagram where I talked about monitoring. So typically in the context, you are going to show monitoring as a separate system, and that's kind of so basically here as you kind of go into the container here, I'm actually talking of New Relic's enterprise observability platform, which is going to provide for the complete monitoring and logging and alerting needs of the overall system. So it kind of comes up. So basically, if you were to talk about other non-functional requirements in terms of security, and if you're using some softwares which are helping from the security standpoint of view, that too also needs to be start being visible as a part of the context as well as the container. So now moving on further, I'd like to take a minute and kind of go deeper into the component. Now we've kind of gone past the phase of container views, which drill down at the technical level. The next level to drill down is how the components which orchestrate together to bring the functionality. Now, a component level is a deeper view of the internal of each container, and we focus, one on one container at a time and break it down to individual components, which are essentially the part of the system, have distinct functions. And a component typically is grouping of related functionality encapsulated behind a well-defined interface and could be a module, subsystem, a class, or a group of related functions or method. In this context, the loan processing system we've been discussing the loan processing API container as an example. So we basically start off with the large box, so the loan processing API in the between, and then basically then we kind of, we also kind of start talking of the other APIs which are there in the system. In this case, basically we talk of the loan application service, we, for managing the loan application submission, credit check service for interacting with the credit scoring system, risk assessment service for assessing the risk based basic assessing loans risk based on application data and credit scores, and loan approval serves for finalizing the loan approval. And interactions again play an important role here. So basically, we also start looking in terms of how each of these components are interacting with one another, and we kind of draw the line. So that kind of gives an idea in terms of how things kind of come together to kind of deliver the functionality. Now, I'll take a minute and kind of talk about the piece where observability. So as you kind of build your application, let's say if you're using an API, you obviously want that level of monitoring, and that's where exactly the New Relics APM, uh, you know, uh, you know, uh, comes into play. So basically, give the application platform monitoring to the need which you want. Additionally, if you're using a web-based application, so in this case, you would probably want a browser monitoring. If it is, and considering there's a mobile application, obviously you'll end up using mobile application or mobile monitoring. And if you kind of deploy this entire architecture on Kubernetes, you probably need Kubernetes monitoring and infrastructure and log, synthetic, and network monitoring and so on. So basically, that's how we kind of go down at the component level and start talking of the observability aspects of how the observability platform kind of comes together to kind of basically support your needs from an observability standpoint, from an enterprise observability standpoint. Now, furthermore, as we kind of go into uh, So as we kind of go into the code, the fourth level of the C4 model, at this level, the focus is on the internal details. So I'm not really going to kind of get into the specifics of the code. So basically, here you're going to have the class diagram, the entity relationships. While the exact nature of the code diagram can depend on the type of the component technology being used. Typically, what you're going to have is classes. You're going to have attributes, methods, relationships, packages, and modules. So it's more again kind of going down to the code level. So as you can see that we've kind of just taken four different views, connected the dots, take it all of your business all the way to the code. I'll take a minute and also kind of talk a little bit of observability. Observability is a key for high system resiliency. And OTA. This involves monitoring and understanding the internal state of the system by examining its output. Is critical aspect of the system design operation in the context of the C4 model. Observability isn't explicitly represented as a separate component, but it's an integral part of the system, implicitly incorporated at each level. So basically, in case of system context diagram, at this level, we may basically kind of go and show monitoring and logging, as one of the observability purposes, and you may end up having a separate box or a separate set of softwares kind of delivering that function. Container, at a container level, the observability can be represented specific containers that are responsible for the aspects of observability. For example, you might want to have an observability incorporated from an application monitoring standpoint with a container level, a log aggregation service, or distributed tracing service. Component diagram, at the component level, the observability can be detailed by showing specific components that are responsible gathering the reporting observability data. For example, component could be responsible logging events, collecting performance metrics, and reporting the data out. At the code level, the observability can be depicted and indicating specific classes and method and function that contribute to the observability. This this could involve showing how logging or error reporting is incorporating into the code or how specific parts of your codes are monitored for performance. Now, by incorporating observability in the C4 model, you can make it clear your system is monitored, how its performance is measured, and how issues can be detected and diagnosed. Now, this is a critical for maintaining the reliability, performance, and overall health of the system. Incorporating observability at various levels, again, system context, you can go ahead and put that as a part as monitoring and alert service container. It can be a logging service and or probably a distributed service, tracing service. Component diagram, it's again going to be a logging module, and so and so from a code standpoint of view. So how simply we've taken the C4 model and we incorporated observability as the same. Similarly, you could also incorporate security and other non-functional requirements which you have from a platform standpoint of view. So just to take one step ahead, rather than showing C4 model in similar vanilla, specifics, rather to kind of going a lot more deeper from a non-functional standpoint of view. In the coming series, we'll kind of talk more from a C4 and a security standpoint of view. Thank you very much for attending the session. And before I kind of go, so I think I want to talk about some important aspects which need to be factored into the C4 model. Well, C4 model can really help visually communicating 100,000 feet view of the software architecture traceable all well to the code. Okay, now if this is used religiously, you're going to have a lot more benefits. Like, for example, traceability of architecture to code, ease of communication via various, views of target audience, improve maintainability, consistency, simplicity, technology and tooling, the choice of appropriate tools, creating, managing C4 diagrams to make sure that this could range the whiteboard and specializing the software design tool, document and decision. While C4 model helps you visualize architects, it's important to document the rationale behind the decisions made in the design process. Security and compliance, you got to ensure that the C4 model and the architecture represents comply with the relevant security and compliance. I mean, in the coming session, we're going to talk a lot more on that. Integration with observability tools, scalability and performance. Now, it's important to make a note, a lot of the non-functional requirements, security, observability, and availability, others need to be factored in this view in order to make it complete. Now, with that being said, thank you for attending the session. I hope you enjoyed it. I look forward to your comments and feedback.